Hello, hello everyone. Thank you for joining the webinar. Uh, we will just wait for another 5 minutes and then we can start off. Uh, if you have any questions or anything, please put it in the chat. If you're not able to hear me, please put it in the chat. Uh, yeah. We will wait for another minute and start. Can you all hear my voice? Can you hear me?
Yes, yes.
Okay, excellent.
Hello, everybody. Good afternoon.
Thank you, Kanchan, for doing this with us. So first, I think we can start the session. First, I will just give you a quick introduction into one-click LCA. It will not be more than 5 minutes, and then I will introduce Kanchan, and then Kanchan will take it forward from there. A few things. If you have any questions, please please send it to us in the chat. Second thing is, if you're not able to hear us or see us, please let us know. Second, and the third thing is, yes, a recording will be sent to you via email so that you can take a look at it later on. All right. So I will just make my screen full screen. Okay. So today we are with Kanchan, who has very graciously agreed to do a webinar with us. So she is going to talk about the role of life cycle assessment within the Indian construction industry context. Kanchan works for BKE, and so I will give you a quick introduction into One-Click LCA. One-Click LCA, we are the world's leading construction and manufacturing and LCA platform. We have three types of tools. So you can do an LCA for buildings, you can do an LCA for roads, bridges. You can also do an LCA for products and get EPD certifications as well. We have integrations with various platforms such as Tekla, Rhino, Revit, uh, all of the design softwares as well as energy software such as IES. Even if you have like a simple Excel file, you can always import it into the software. One-click LCA, we have the largest set of data sets because we integrate with different types of databases for LCA data sets across the world. We have EcoInvent dataset as well as other EPDs that are available on various program operators. Um, One-click LCA, we work with some of the biggest names in the industry like AECOM, Ramboll, and these are all clients who are in India itself. And of course, we work with PKE. We try to do as much as we can. Uh, so we have a tool for every stage of the design. We have a tool for strategy, for concept, for design, for construction, for refurbishment. If you want to see how circular your design is, you can check that. All of our reports are compliant with ISO EN as well as various ESG frameworks such as GRESB, SBTI, CDP. Okay. So now I can talk about Kanchan. Kanchan is an environmental architect and professional with 15 years of experience in the sustainability sector and development. She is a professional with versatile skill sets in the field of sustainable design, green buildings, and energy conservation. She is working as an associate, as a senior associate or senior partner with BKE. During the session with Kanchan, we are trying to understand how the embodied carbon concept works in terms of an Indian context, understanding the embodied carbon and LCA, the need to drive decarbonization on a national level. How can LCA help you in making informed decisions throughout the stages of the construction project? The challenges that she has faced, how the software has used, how the software she has used, and what are the best practices, and what is the upcoming and future outlook for India to tackle embodied carbon and what can be done? There is also a poll that is also open right now. So if you would like a personalized demo on how to use one-click LCA in your project, please say yes in the poll. All right. So now I will stop sharing and I will ask Kanchan to share her screen and she can start.
Right, great. Thank you, Natasha, for the introduction. And thank you, everybody, and Multic LCA for having me here, sharing my experiences in LCA and the construction industry till now. So let me share my screen and let me know once that's visible to you. Are you able to see my screen?
Yes, we can, Kanchan.
Great, great. All right, so what we're going to sort of skim through today is, of course, a little bit of background. What do we mean by LCA? What has been the industry approach? Choice of materials, a few case studies, and further trends to set sort of, an open-ended, discussion on maybe trends to set and even carbon negative to an extent. So to begin with, for those who are not very familiar with the with the sustainability jargon, with life cycle assessments, I just thought that this would be a good point to start off because you hear all these terminologies. You hear GHG, you hear embodied energy, then you hear embodied carbon, operational energy, operational carbon, and now LCAs. So basically, a quick sort of glimpse of what all these mean to begin with. So GHG stands for greenhouse gases, basically. These include primarily six gases, that is carbon dioxide, methane, nitrous oxide, and the HFCs, sulfur hexafluorides, etc. So basically, these gases are responsible for trapping excessive heat around the Earth's atmosphere and thereby causing the warming effect. So it has been the world mission to basically reduce these GHG gases. And just for everybody's info, carbon dioxide is a naturally occurring greenhouse gas, and which is also responsible for maintaining the average Earth's temperature to 14 degrees, so that life can exist on Earth. However, excessive emissions of these gases is what has been causing the warming, and the 1.5 and 2 degree threshold for us to, the increase that needs to be contained is why we are all actually here. So that is GHG. Now, embodied energy, basically, you might have heard this terminology way before also. I mean, anybody who is an architect or from the civil side would have definitely gotten to know that, okay, the embodied energy of bricks is so and aluminum is so and so, which is usually measured in, say, megajoules or MJOE or any other unit, energy unit of measurement. Now, today, when we talk about embodied carbon, we're actually talking about this same energy expressed in CO2e equivalent. So CO2, the E stands for equivalent. That is because all the GHG gases that are there, they are all measured in terms of carbon dioxide, which is a standard sort of universally accepted norm. So, for example, methane is way more potent than CO2e. So, it is translated into the CO2e language and expressed as one terminology all across the globe. So, when we convert this energy into and express it as carbon, we start calling it embodied carbon emissions rather than embodied energy in manufacturing, which basically means which is the sum of all the energy and resources that are required to manufacture anything on this earth, basically. And more so right now for this particular session, we are referring to construction materials or the building, building components, etc. Similarly, operational energy, when we in its use phase, whatever we consume in terms of resources. So, energy refers to any kind of electricity, heat, steam, fuel, any sort of energy that we use, and its expression in carbon then sort of becomes as the operational carbon, right? Pardon me for my throat today. Moving further, so all these terminologies, how does LCA plug in to all of these? So LCA, which is life cycle assessment, it is basically a process to evaluate, the entire sort of boundary of effects that any product, project, organization, anything at all, whatever scope you want to define, has from its birth to its, end of life or even to its reuse. So basically, it is the entire scope of impacts that one measures when we say we conduct a LCA. So it is not the instantaneous benefit or the instantaneous impact or only the use phase impact that one would see when we talk about an LCA. So it is that entire, hence the name life cycle. It is from its birth, that is cradle, to it could be its grave or even back to the cradle if you are using that material. And the difference between probably GHG and LCA also is that when we look at life cycle assessment, GHG is one component on or one measurement factor in a LCA. There are other environmental factors like eutrophication potential or impact on, say, freshwater, acidification potential, ozone depleting potential. So there are many other environmental impacts which a particular product, project, or organization could have, and not just the carbon emissions or not just the CO2e equivalent, basically. Right. So we know, I'm going to very quickly run through this slide. We know that the construction sector sort of is, a substantial contributor to both direct and indirect GHG emissions. And that is the reason why we are addressing the construction sector. Another reason why we're also addressing the construction sector, that it's going to cause a ripple effect, and it's going to cause a change in the supply chain of all these building materials and how they are getting manufactured in the first place. So we know that GHG contributions in the building construction sector basically are caused from energy use in building, transportation to and from buildings, other resources like water or waste management, and the construction of the building itself. And how we are going to reduce it is through clean energy offsets, is by using public transport, by using more harvested recycled water, and in case of building materials, by using more and more recycled content and using more information on the CO2 footprints of these building materials. So, like I mentioned, what the life cycle assessment is in plain words, you can see that it is an assessment which is also based on a specific method of calculation, which is governed by the ISO standards 40 and 44, and they offer a scientific way basically to assess and to then start mitigating climate change. So one may say that it is a first step, and carbon footprinting itself as one of the parameters starts becoming the first step as a part of the LCA. And it is particularly, I would talk about the benefits and how to really use the LCA in the real life scenario. But typically, you will find a lot of product manufacturers, a lot of equipment or technology manufacturers talking about the life cycle impact of their product in a sort of a positive reference. So, how can one use a LCA? So, if you're a product manufacturer, you can conduct the LCA of your particular product and establish what are its base impacts, environmental impacts. Uh, Probably we are not at a stage where we are comparing the products to each other, and if they are comparable, they're declared as comparable. But one set of users is product manufacturers, wherein any product that I'm manufacturing, be it in the construction industry or any other industry, uh, I need to do my life cycle assessment and find out what my impacts are, including the GHG, including the carbon. And the second part is as a project. So if I am a project developer, architect, engineer who is responsible for selection of products, a project will have a sort of an assembly of thousands of products. But do I have the environmental profile or the carbon footprint profile of each of these materials? And can I make a sort of a alert choice on, okay, this is a low carbon material than this one, and hence I need to prefer a particular material. So basically, you would be in either of the roles, either from the manufacturing side, where you're very focused on the materials that you are producing, or from the project side, where you are responsible for actually selecting low carbon materials, which in turn drives the manufacturer towards manufacturing more low carbon materials. And you can, whatever, in whichever role we are, the LCA that we come up with typically can be used for two things. One, it can be used for reporting purposes. So we see that currently the Indian market is in a phase of disclosures, where we are doing a lot of public disclosures in terms of our impact, emissions, in terms of the health of business. So you might have heard about ESG reporting, where we are reporting every big and small aspect of how any entity is run, right? Be it sort of a portfolio of projects, be it an entire business, be it a manufacturing unit. So one major stream of LCA is simply disclosing and knowing what the impact is to begin with. Once you start on this journey, then we go to the reduce phase as to where all can I curtail my reductions, where all can I curtail my impacts. For example, if you're a chemical industry, wherein you will see that probably the GHG emissions are not that high, but maybe the acidification, eutrophication impacts on water are very high. Then what can I do to actually reduce that impact? So basically, the takeaways here are that you are either in a manufacturing capacity or in somebody who orders the materials sort of a capacity, and you can use this LCA for your reporting purposes to know what your baselines are, or you can use it to make a decision to actually reduce your impact. So that is sort of, I wanted all of you to sort of see through the jargon of, all these words and terminologies, which seem complex, but in the end, what we are trying is to avoid usage or to reduce the resource consumptions. And the LCA is purely using us to compute that reduction or that positive impact or negative impact that we might be causing on our projects due to this decision making process. So moving further from LCAs, so you will further see terminologies like EPDs, which is an environmental product declarations. Those who are already working in the green building sector would have already known and heard and maybe used EPDs, which is again a disclosure platform where the materials environmental profile is declared and published. Okay, so basically, LEED sort of first started promoting use of EPDs in the construction sector. So any LEED, say version 4 or 4.1 onwards certified project, you would find is asking for EPDs as a part of the material compliances. So this is a third-party verified LCA, basically, and which is published on various platforms and program providers such as the International EPD System, the EPD Hub. There are many more in the EU, but primarily the Indian market uses the EPD Hub and the EPD International System to sort of declare their EPDs. So that is like a fully verified version of an LCA. Then there is a product LCA, which sort of we may not have very stringent norms in terms of who should verify the LCA. So it is probably for internal purposes. It is for establishing your own baselines and your own sustainability journey internally. And then you have only carbon footprint report, the carbon assessments, which looks at only the carbon part out of the entire LCA. So these are the three levels in which products in India are generally looking at life cycle assessments and are using them for various purposes. Like I said, LCA for all sorts of products is available. This is, I think, this is what the One Click LCA site sort of gives us, that it is not just construction products, but it is electrical products, any other manufacturing good or any other service which we are creating that can be assessed using the tools. And just a pictorial depiction of that LCA, that it goes right from the raw material extraction until the end of life. And like the takeaways from here are you can actually scope out your LCA or your life cycle assessment from cradle to gate, cradle to grave, and cradle to cradle, depending on how much control you have on the data and the processes therein, right? So you will see that when we start talking about extended manufacturers' responsibility, you will see that to promote circularity, some materials could come back, through the recycling mechanisms to the manufacturers, for example. So anybody who is taking these efforts on circularity will definitely score better or will show a better impact when we do a cradle to cradle kind of an analysis. So, but the Indian industry right now is poised at different levels for different products. I mean, it depends on how the product or the project is keeping its data. And if they have a good data keeping for cradle to gate, so everything within their control, then that is the minimum sort of scope that one would need for the LCA. And typically, cradle to gate is what a lot of people are going ahead with. unless it is mandated by the EPDs to, consider Cradle to Cradle or Cradle to Grave. So like I said, various ISO standards for doing the LCA work, for reviewing the LCA work, for the verification part of the LCA work. So these standards are sort of available for one to refer to and then work accordingly. Now, in terms of LCA compliances, what we have come across is we just categorize them as regulatory compliances and voluntary compliances. So, for example, SEBI has already mandated the listed companies to sort of top 1,000, I think 2,000 now listed companies to do BRSR, which is business responsibility and sustainability reporting. As a part of which, again, the scope 1, scope 2, scope 3 sort of emissions are required, and a lot of LCA work goes under the scope 3 domain. And that is where I think the regulatory frameworks have started asking for carbon footprinting of their products, particularly for manufacturing units. Another place where there is a regulatory interface that we see with the LCA work is EIA projects, wherein the MOFCC, while granting environmental clearance to projects which are more than 16 lakh square feet or 1,50,000 square meters, will ask for a carbon footprint report which is based on LCA. So basically, you would have to model your entire project or the BOQ. I mean, all the items, the major ones used for construction, and find out what your embodied carbon footprint is, and then how you are mitigating some of it by using, say, recycled material, local material, etc., etc. So that is a kind of again interface that we have found on the regulatory side. Of course, on the voluntary side, you will see that the green building rating systems, be it LEED, RIHA, IGBC, EDGE, are all promoting a lot of LCA work in the building industry. Further, I mean, LEED has sort of started asking for EPDs and the whole building LCA simulations, and has given a lot of, I would say, momentum to the ask for LCAs to the manufacturers. And moving ahead, CII as well, through their Green Co certification and through the Green Pro certification. So Green Co is Green Company certification. Also has a huge weightage given to LCA. So Green Co is typically done by manufacturing companies of all scales, small, medium to large, and very large. So all of these manufacturers are required to actually conduct their LCA as per standards, as per the ISO guidelines, and this is an inherent part of the Green Co rating with a very high weightage. Also, CII Green Pro certifications with over, almost I think 7 to 8,000 products in India already lined up in Green Pro. Have sort of done their LCAs, and that is also again a part of the CII Green Pro rating, and EPD certifications, which LEED has been pushing for and which a lot of markets outside have been asking for. So these are all sort of the voluntary mechanisms where you will find the need for conducting LCAs and then maybe getting them verified by a third party, by independent and accredited third party, depending on the requirements of the project. So, embodied carbon and operational carbon. I mean, a few years back, the talk was that okay, operational is quite high, so let's not look at embodied currently. But now, in the recent couple of years, you will see there's a lot of talk going on embodied carbon as well, and not just operational carbon. And there's a reason for it. When you look at a business as usual project, you will see that around 12 to 20% of embodied emissions come from operational carbon. Come from embodied carbon, and the remainder 80% roughly are into the operational, are attributed to operational carbon. But as in how we are sort of going up ahead, implementing energy efficient projects, implementing more and more green buildings, the operational carbon has of course, the proportion has sort of started to come down. And now with projects looking at net zero or near net zero kind of scenarios also, it is the embodied carbon that is then left with the project to be offset, to be mitigated, or to be equated to a sink or a reservoir of carbon, basically. So it is sort of very important to understand what type of control a project has on the embodied side of things and on the operational side of things. Both are important, and like I said, as the green building movement is going ahead, they are sort of going to get to 50-50 very soon. So typically we did a sort of a fact check. These were this 12 to 20% or 80 to 85% were numbers which we found through secondary research. But we did a sort of a fact check on live projects where we used one click LCA to run various types of projects. Here on the screen you see residential and commercial projects where for various developers, where we have found that yes, these proportions are the same in the Indian context. So we actually model the BOQs of our projects into one click LCA, and we have gathered that yes, this breakup of you know uh, 13 to 87 or 12 to 88 is true. Um, Here is sort of a visual representation for you of the life cycle assessment. Like I said, that the impact accounting actually starts from the raw material supply, which is A1. These are standard terminologies used all across. You will also, if you're already using any softwares for LC, you'll also see these A1, A2, A3, right up to D, which is beyond the building sort of life cycle stage or a recovery sort of stage. You will see all these stages which are here. Now, as a starting point, like I said, we could do simply, depending on whether you're a manufacturer or whether you're a proponent or a developer, you can pick which phase do you want to implement, which is under your influence, and then sort of work towards mapping of that stage. But the LCA typically will involve everything from raw material extraction, its transportation, manufacturing, its transportation to the construction site, its installation on the construction site, then the use phase of the material, and then the demolition or removal of that material from where it was placed back to recycling. So that is how the sort of even the software breaks your impacts into these gradual sort of phases as the product moves ahead. Now, how this is sort of also related to scope three, I did mention about that LCA will sort of is becoming a part of the scope three reporting of many entities. That is because the moment you create a new asset, you create a new facility, you build a new building, or you take in a building on lease and do the interiors, you are going to see a spike in the GHG of your sort of organization. That is because you have invested, into this project and consumed these many materials as a part of your scope. So in the ESG domain, basically scope one and scope two are, the most, most of the companies are now have completed, I would say, their scope one and scope two inventorization. So scope one and scope two emission inventorization. And slowly, steadily, people are now moving towards the scope three inventorization. That is where all your goods, services, your assets, all of them fall. And this spike in the scope three is something that you would be able to really control if you opt for low carbon options or low carbon emitting materials and components, equipments in either their manufacturing phase or their use phase. So, which you will know only when you actually ask for the LCA of this particular product or equipment. So you would also find these embodied carbon benchmarks, on the one click LCA sort of website, where if your whatever your model will immediately be compared as against the entire inventory that the software per se has, and it will also categorize where you stand. Um, Going ahead, I'd like to touch upon a little bit of the industry approach, and LCA. So up till now, we saw what LCA is, how it can be used by different stakeholders, what is the scope of that LCA overall. But like I said, I'd really like all of you to see through the complexity of how it is to be done, but and to keep it simple. I would say that to make a real difference to a project, we could simply follow these four things which are given on the screen for the construction industry. So first and foremost is avoidance through design. So, for example, it could be architectural, structural design for material use optimization. So, or it could be dimensional planning to avoid purchasing extra materials, and the C&D waste reduction with good skills and workmanship. So, what I'm trying to get to here is that our basics of actually building in a sustainable way or uh, executing a development in a sustainable way remains same. We are sort of using LCA as a tool to probably make better decisions. So, for example, if there is a structural design, which is scenario A versus scenario B, where you can immediately prove that okay, this is the long-term LCA impact, and in connection with your ROIs and your financial calculations, it is a more convincing way to sort of go forward. So the LCA can be actually used as a tool for decision making as well, to push the projects towards avoidance of unnecessary installations. The second part of it is recycled content, as simple as it has been there since the beginning. But even if you look at the one-click LCA library or the eco-invent data, you're going to find a lot of options for materials with recycled content in them. Of course, we know that material with a recycled content will have a lower embodied carbon. Or lower embodied emissions as compared to virgin materials. So I'll also run you through some values of how recycled content affects the carbon emissions that we can map. The third thing is the materials with some kind of an eco-labeling. It could be EPD, it could be Green Pro, it could be any other eco-labeling program that you can come across where the environmental profile of that particular material is known. Okay, so with recycled content, what happens is we go with a base number that, okay, glass has say 18% recycled content. And now say, a manufacturer has innovated and he has come up with a glass which has 24% recycled content. So we go by the simplest matrix that is available to us. With the EPD or with Green Pro or any of the eco-labeling programs, what happens is for sure that per square meter of glass is so much CO2 equivalent. So that is the kind of difference between what we've been doing till now in the green building sector and what has changed in the last 3 years with having more information, more profiling, more disclosures on the material side. And last but not the least, circularity in buildings, whether we can design buildings for dismantling, refurbishment, and that question to be asked. I think we're yet to get there. Whether we are, whether we should be creating dismantleable buildings and components which can, sort of save a lot of embodied carbon. So when we look at LCA as a tool for decision making, there are two differences that we have learned over time. One is the choice of material based on its own LCA impact, which is that these are materials which just sit with the building. They do not really influence the performance per se or ongoing operational performance of the building. So these are just going to be there with the building, right? And there are materials which will have a substantial impact in the use phase of the building. Like, for example, if you can look at HVAC components, if you look at building envelope components, so like you can see at the bottom of the page, there is a difference between the performance of single clear glass, the performance of, say, a DGU, for example. So would you now, based on this, say that, okay, let's not do a DGU because it is a high embodied carbon material? And let's go with single glass. My God, it is, thrice, the DQ is thrice, right? So I cannot base my decision simply by looking at the embodied carbon numbers. I'd have to look at how it really affects my operational phase. So for example, the DQ is going to land me saving my operational energy, right? To a very large extent and over the life of the project, maybe 30 years, 40 years, 60 years, which we assume as standard. So, I also have to consider the use phase while making this decision today, right? Even if single glass looks lesser to me in terms of its embodied carbon. So this is something to really remember as to how to categorize your materials and which are the materials where you can, straight away compare impact to impact and go ahead with your selection, and which are the materials where you need to consider the use phase or you need to consider the, further phases in the life cycle while making that decision. So these are a few examples of the LCA that we sort of conducted. So you can see the bubble diagram showing you which are the larger, which are the most contributing, components in a building, vis-a-vis which are the minor elements. So one can actually exhaustively model all of these materials, building materials, and derive from this. So if I were to do any decarbonization strategies, I know which are my priority areas. I know which are the areas I need to decarbonize first. And it's most likely that these also have high costs, these materials. So basically, it is sort of a win-win situation where we try to save any resource using LCA. It also adds to my profits and it also reduces my environmental impact. So that is how the interpretations from one-click LCA can actually be used in order to make a change, make gradual changes, project by project, material by material, process by process, in any of your roles that you're playing. So sort of through our works have done exhaustive number of projects where we've mapped the carbon emissions of projects right from residential, commercial, industrial, public, semi-public. So including its operational phase as well. So these are the ranges that we have found in the Indian industry based on actual live data on live projects that we have sort of come up with. Now, there are a lot of questions that one comes across whether this value, sorry, this value is less, more. So currently, there is no benchmarking we have for whether this should be, this is less, this is more. So we're not having any benchmarking in terms of just the embodied part of it. We have benchmarks for operational energy, like for example, we have EPIs or we have some comparisons with the standards of ASHRAE, where operational energy consumption is benchmarked. However, there is no benchmark for embodied carbon in various types of, say, sectors or types of buildings. So I feel there is a need for standardization of embodied carbon lists. For example, if we are comparing projects, say you are doing a project and I'm doing another, we need to have a standardization of this list. So maybe it is the top 10 most important materials in the residential segment or the commercial segment, which we need to sort of fix. And mostly from our studies, we know that it is not more than these 15 to 20 materials which we need to sort of prioritize and push. Of course, every material and every installation matters, but as a starting point, if across your projects you have a fixed list of materials or components, it will be easier for you to compare and create your own benchmarks, which actually is the need for the industry today. So, when in making a better choice, of course, you have various materials that are available. So, for example, for aluminum, you will find aluminum which is 4 kg CO2e per kg of aluminum up to 9 kg CO2e per kg aluminum. So, whether there is a cost difference in these, whether the manufacturer has made it carbon neutral is something you can find only from the data disclosed by each manufacturer. Moving further to the simplest of the examples, we know that we use a lot of recycled content in the reinforcement steels that we typically do. So you can find the difference here on screen with with steel which has no recycled content versus steel which has 60% recycled content versus 97% recycled content, and you will see how the CO2e per kg has dropped. So this is again a material which is which is used in huge quantities into a project. So obviously it has impact on the total embodied carbon once you multiply. With concrete again, which is the highest of all in the construction industry, you will see that it starts with almost 396 kg of CO2 equivalent per cubic meter of concrete. Here we've assumed M35 concrete without with only the typical 10 or 15% fly ash mix. But when you do say 60% GGBS in the same concrete, it halves, almost becomes to 172 kg CO2e per cubic meter. And further, when you look at carbon neutral sort of concrete products, you will see that there are companies who have reported this value to be minus 25.9 kg per CO2 per cubic meter of concrete. So that is how sort of a manufacturer can also sort of influence, a carbon negative material or report carbon negative materials to get preferences by projects which want to reduce their scope. So you could take any material and you could research based on the inventories that are available, based on monthly LCA data which is available to the Indian market, and see if you can make a better choice in each of your projects. So typically, the first thing would be to get a LCA done. I mean, if this is particularly for product manufacturers, where the first thing is to do the LCA, the next thing is to probably um, get sort of a green pro sort of a rating, and then probably go ahead with the EPD. So that is sort of the course that a product manufacturer would follow. These are a few projects where we used GGBS, high-rise projects where GGBS was used. These are by default green building projects, and which landed up saving us a lot of costs and a lot of material. So at the time, these were done really quite a few years back. So at the time, you can see that we've done manual calculations, but the same is now very easily possible using materials. Again, reduction in weight due to AAC blocks, the embodied reduction cost due to that by saving steel and concrete. Similar product where PSC industrial waste, again, so GGBS was used exhaustively, the calculations for that. Then another case example where instead of doing the conventional brickbat sort of some kind of a filling for toilets and restrooms, we used slump piping, which landed up saving us quite some structure. So again, the estimations for this. Now, sort of the open-ended part of the discussion that I'm coming to. Natasha, how long do I have? Because I think I have quite a few slides left.
We have another 10 minutes, so
Great.
it's good. Yeah, yeah.
Okay. Okay. All right. So, based on our analysis and experience in the industry till now, what we have gathered is there are two focus areas where we need to look at. One is concrete and how to decarbonize concrete or reduce concrete. So, if any of the projects land up saving cement or concrete, they will definitely make a big difference to the decarbonization at a sort of a large level. And the second part is not a part of the embodied carbon, but a part of the operational sort of carbon is low energy cooling system. So mainstreaming low energy cooling system is another area where you can make a double sort of an effect. One is the operational energy in a low energy cooling system is almost 1/8, if not 1/10 of a conventional air conditioning system, and two, the refrigerant, the quantity of refrigerants that a typical air conditioned project would use would be way higher. So all of these CFCs, HCFCs, which are not now used, but HFCs and the rest of the new age refrigerants which are coming, if they could be reduced to a good extent, their direct impact on climate change is going to reduce. So the benefit is twofold. So very quickly, I'll run through a few case studies and maybe also take you through a lead report that we have done. So this particular building, again, like you can see, is a very near net zero sort of a project where I am sort of propagating mainstreaming low energy cooling systems. These low energy cooling systems can also be modeled using one-click LCA, and their long-term impact on energy can also be modeled on one-click LCA. So for everybody's reference, you can toy with your demo versions maybe and check out. And so here we've used like a combination of systems and not just say conventional VRF sort of system. You've done a direct and indirect direct evaporative cooling system with the earth air tunnel, and which has reduced our HVAC installation substantially. So instead of needing 1 TR for just 250 or 300 square feet, we've landed up installing 1 TR for 625 square feet. So that is the power of, say, climate responsive HVAC design in alignment with the climate responsive architectural design. So while we are learning about LCAs, I want to sort of bring to the forefront that design itself in itself is a powerful tool for avoidance and reduction, and it can very well be justified using your life cycle assessments. So these are a few quick images and of sort of the project that I wanted to show. And then we go to the new age carbon negative materials. So any of the bio-based materials that you use. So it could be mycelium insulation, which is like derived from a plant sort of source. It could be lime, it could be any grass-based board. Recently, we bumped across a board called Safe Board or Desert Board, which uses date palms basically to create plywoods. So any sort of bio-based material is going to capture, is going to sort of negate, and they're going to be called as carbon negative materials. So wherever you have the opportunities to use these kind of materials, they're going to hit that minus sign on your, carbon footprint inventory. So, and latest again, open for research and something that even I am looking at, and all of you are welcome to look into it. Is the latest IPCC report says that over the lifetime, concrete structures absorb back 50% of the CO2 that they emitted during the production. So some research shows 30%, some research shows 50%. But again, a very interesting question to pose to industry, especially when concrete is the sort of the largest contributor overall. So I think that is all from my end. I hope in these 40-45 minutes I could sort of, interest you and, take you through some of the experiences we've had while working in this sector. If quickly you would want me to sort of also show how the one-click LCA report looks.
Yes, you can go ahead, Kanchan.
Sure. Uh, I'll just reshare my.
Yes, you just have to reshare the screen again.
Right. So this is the same project for which I showed you the low energy cooling. So uh, basically, this project also, like I said, we did slung piping, we mapped the impact of ACs and a few other measures. And you will see that one click LCA basically looks at all of these list of impacts that are there. So it looks at global warming potential, it looks at acidification potential, ozone depleting potential, eutrophication potential, formation of ozone in the lower atmosphere, and the depletion of non-renewable energy. So basically, when you model, this is like the dashboard that you would get on one-click LCA, and you model your base case and your design case. You get your values based on whatever measures you have taken to decarbonize. So, for example, the measure could be as simple as using a material which is located very close to your site. So, it's going to reflect, if you can see my cursor here at A4, transportation to site. So, it's going to start reflecting there. So, the more accurately actually you model all your quantities, your distances, and whatever goes into the project, actually, so to speak, the software will have the capability to actually map that very nicely for you. And also in terms of the representation, so finally the baseline case versus the design case, LCA impact editor, these are all the impact categories in different, like I said, GWP, acidification, eutrophication, etc. So you will also get quick comparisons of your baseline versus your design case. And the actual extracted report will look something like this that you see on your screen right now. So it's a long report, and you can get which one's the highest one. So if you see here, the most contributing materials is the RMC, is the reinforcement steel, then again a certain grade of RMC, and so on and so forth. So you can also sort of check, which is your most contributing element, which is your most contributing component in the building, and sort of get an exhaustive report like that. So yes, so that's all from my end, and I hope I have been able to share what we've been doing, and how you can sort of also take it up in your own practices, in your own capacities, because the sky's the limit here. You can use LCA for any sort of positioning that you may be in the industry.
Thank you so much, Kanchan, for such an excellent presentation. Kanchan, I have one question that is when, see, your company is a very data-driven sort of, you have a very data-driven approach to design, to sustainability. In terms of data points, what are some of the challenges that you have faced? You know, like the example that you showed us also for the cooling system. What are some of the challenges that you face, and how you are overcoming that?
Yeah, data is everything. I mean, in the ESG domain, any accounting, any measurements that we're doing, of course, we have to be very careful with the data because the stakeholders in the construction industry currently are not fully aware of what LCAs are or even about carbon footprint or measurements. So you really have to ask for very basic raw data. Like for example, for us, getting the quantities right, as built quantities right, was the only simple thing. So I think as consultants in this fraternity, we would break down our requirements, and we refrain from asking very complicated questions and do a very simple Excel based sort of inventory for them to fill up. And of course, we also have to go through the inventory in terms of whether sometimes because there are lot of units involved. So sometimes you get very extremely incorrect units, and then you can make out from the results also because you now have a fair idea. By now, we have a fair idea of how this should look like, and that's how we also proofread all the entries, the data entries that we get. So I think breaking it down into simple things to ask is the trick for it. Because if your data collection goes wrong, then it becomes very difficult to correct it later and find any discrepancies there.
Thank you, Kanchan. I don't have any questions from my side. I don't see any questions
Uh, I
in.
I can see one question here. Isn't it true that the cost of
Oh,
by
yeah.
I think by Rudolph de Souza. Isn't it true that the cost of green material to a contractor is higher compared to standard materials? And how does one justify it to the management since operations are not in contractors or builders' hands? So how do yeah? So yeah, this is a very yes, the capex could be slightly higher for green projects. But I mean, if it were sort of integrated from design, then those costs can be controlled to a very large extent. And it is precisely for this reason that once you put the the operational numbers in the LCA picture, you would know that okay, this is going to pay you back in like literally less than a year or slightly more than a year and so on. So in fact, it helps us justify the costs quite well. And I think the industry has in many areas moved beyond this point that okay, they're sure that these there are ROIs, and hence they will simply go in for the measures. But you're right, you're distinguishing between core and shell versus sort of a completely fit out project. A completely fit out project definitely reaps the benefits by themselves, but I'll tell you what's happening on the core and shell side or the contractor side or developer side. So this is no longer remaining as a add-on or an additional requirement. Environmental compliances and green buildings is becoming the benchmark. So if he doesn't comply today, he's going to lose out on business tomorrow or even today for that matter. So if you look at all the, for example, CPWD, PWD contracts, they are blindly, they have, say, a green building criteria in them, right? So I totally agree that the contractors are not fully, they have not fully understood maybe that, what this entails and what really changes in the BOQ specifications. But it is the push is completely there, and there is nowhere else to go other than to work on efficiencies and reductions. So it's already become like a stick approach. And there
Yes.
is like I'll give you an example. We work with a lot of developers, and so agreed that the developer or the contractor himself is not going to occupy that space, not going to operate, not going to reap any benefits in the operational carbon uh, per se. However, the kind of questions that consumers and say the companies actually leasing these properties are having say it all. I mean, they are extremely aware about their scope 1, scope 2, scope 3, and they are going to lease a property only which is at minimum compliant to the sustainability norms. Otherwise, they're not going to comply to the sustainability norms. So that is where it's going now.
All right, Kanchan, thank you so much for answering that question so well. Um, I don't know if anyone has any other questions. You can just unmute, I guess, and ask the question also if you're not sure how to reply on the chat. All right. Okay. I think we can end the session here. Thank you so much, Kanchan, for taking the time out and for doing this. It was very informative, and I hope everyone learned a lot from this session. There is also going to be a part two of the session that is on end of life modeling that I will be doing, and you are also welcome to join that session as well. If you have any questions, of course, you can always send us an email at sales@oneclicklca.com. Uh, yeah. Thank you again, Kanchan, for doing this and for taking the time out. And really appreciate it that you're doing it when you were quite sick. So thank you.
Thank you. Thank you. My pleasure. Thank you.
Thank you. Bye. Have a nice rest of the day. See you.
Bye. Thanks, everybody.
The recording will be sent to you as an email as well. So yeah. All right. Thank you.